Today, we're tackling Leetcode problem 2206, divide array into equal pairs. The problem gives us an integer array called nums, which always contains an even number of elements, specifically 2 times n elements. Our task is to figure out if we can divide this array into n pairs, where each element belongs to exactly one pair, and the elements within each pair are equal. If we can do this, we return true, otherwise we return false. Let's walk through the provided examples. Here's a solution using sorting. The core idea is simple. If we sort the array, all equal elements will be adjacent to each other. We can then iterate through the sorted array, checking pairs of elements. Let's break down the code. First, we sort the nums array using nums.sort. This places identical numbers next to each other. Then we loop through the array, incrementing by 2 in each step, for I in range, 0, len, nums, 2. Inside the loop, we check if nums is not equal to nums plus 1. If they are not equal, it means we cannot form a pair with equal elements, and we immediately return false. If the loop completes without finding any unequal pairs, it means all pairs are valid, and we return true. The time complexity is big O of n log n, primarily due to the nums.sort operation. Most common sorting algorithms have a time complexity of n log n. The space complexity is big O of 1, or constant space, because we're sorting in place and not using any significant extra memory that scales with the input size. We're just using a few variables for iteration. Now let's look at a more optimal solution using a hash map. This approach avoids sorting, which can be more efficient. The idea here is to count the occurrences of each number in the array. If every number appears an even number of times, then we can form pairs. First, we initialize an empty dictionary called counts. Then we iterate through the nums array. For each num in nums, we update its count in the counts dictionary. Counts.get num 0 retrieves the current count of num, defaulting to 0 if num isn't already in the dictionary. We then add 1 to this count. After counting all numbers, we iterate through the values of the counts dictionary. These are the frequencies of each number. For each count, we check if it's odd using count modulo 2 is not equal to 0. If any count is odd, we return false. If all counts are even, we return true. The time complexity is big O of n, where n is the number of elements in the nums array. This is because we iterate through the array once to count the numbers, and then iterate through the dictionary, which, in the worst case, can have n distinct elements. The space complexity is also big O of n, as in the worst case scenario, all elements in nums are unique, and our counts dictionary will store n key-value pairs. Let's explore an approach that leverages the constraints of the problem for potentially even better performance in certain situations. The problem states that the values in nums are between 1 and 500, inclusive. This allows us to use an array instead of a hash map to count frequencies. We create an array named counts of size 501, initialized with all zeros. The index of the array represents the number, and the value at that index represents its count. The code iterates through the input array nums. For each num, we increment counts by 1. Finally, we iterate through the counts array. If we find any count that is odd, meaning that number appears an odd number of times, we return false. Otherwise, if all counts are even, we return true. The time complexity is still big O of n because we iterate through the nums array once. The space complexity is big O of 1, or constant space. Even though we're using an array, its size is fixed at 501, regardless of the size of the input array nums. This is because of the constraint on the range of numbers in the input. This is technically constant space, because it doesn't grow with n. That covers 3 different approaches to solving the divide array into equal pairs problem. Remember to consider the problem constraints when choosing the best solution. Let me know in the comments what Leetcode problem you'd like to see explained next. And if you found this video helpful, please like, subscribe, and hit that notification bell. You can also help me continue making videos by donating at buymeaboba.com, link in description.